The results are better than P over Z. P over Z in the world of reserve evaluation is kind of the gold standard for determining reserves for gas wells. This is better than P over Z because there's no shut-in required. Nobody ever leaves a well shut in long enough on a P over Z to really have it stabilize. So you're always cheating yourself out of reserves. Since there's no shut-in required with this analysis, it's actually better. If you've got electronic recorders out there, you can get the pressure data immediately, after you turn the well on. Then you can calculate permeability in skin. I think we've looked at some charts. You'll see what the problem is there. I don't really count on a lot of that data. It provides an actual drainage area, assuming your reservoir parameters are correct. And the software provides for a numerical simulation. Where that's handy is, as I told you before, with the well testing algorithms, anything past a couple of months on an oil reservoir is suspect because of the rel perm changes and the bubble point and all that. This software actually allows for a numerical simulation that accounts for all that, so you can do extended forecast of your oil rates. When you're doing this, as you're gathering your data up here, casing pressure is better than tubing pressure because it's a static column. It's all corrected back down to bottom hole pressure, but if you've got casing pressure, that's better. Okay, here we've got a well. It's down in the Gulf Coast. This is the data that was sent to me. This well was limited, was curtailed, if you can use that word, to 20 million a day. And so you can see it's just plugging right on along here with a couple of shutdowns for whatever. 20 million a day, 20 million a day. Then they lowered it to about 15 million a day. But no, there is no effective decline on this. I mean, you might decide, okay, this is actually a decline rate here, so what does that come up to? Well, you've got about 5.5 BCF, 5.6 BCF based on this decline rate. But the question is that really a decline rate here? Since, like I say, it's produced for, what is that, 60 days? Yeah, since it's 60 days worth of production, at 20 million a day with no decline. What are the guy was wanting to know if he should drill another well. So, it's kind of a busy plot, but what we've got here is these right here are the flow rates for the well, the daily flow rate. So there's that 20 million a day up here, and then drops down to this 15 or so. Okay, these points here are the tubing pressure points that I had to work with. I had a packer in the hole, so I couldn't use casing pressures. But you can definitely see a decline in the tubing pressure, despite the fact that the rates are constant. So you plug all that into the magic mystery box, and you wind up with this curve here. This side of the curve is your transient data. If you remember, transient deals with permeability in skin. And this side of the data is your depletion stem. So you can have multiple permeability in skins, but no matter where it starts out, everything finishes up on this depletion stem. And you can actually grab this data set and move it around until it all fits. And I think you can see that we've got a pretty good fit on this depletion stem here. And what it's showing us is that our actual gas in place is about 1.9 BCF instead of the 5.5 BCF that you got using a conventional decline curve type method. This is another way to look at the data. This is called the flowing material balance plot. Might be a little easier to understand. And you can see that we're drawing a line right through these data points here at the end. And it's coming out with a 1.9 something BCF. So there's no way you can adjust this data to come out with that 5 BCF number. It'd be way over here someplace that we originally saw. And this is after, 60 days of production, I'm making these forecasts. So now what I've done, like I say, I only had data through about here when I made this projection. I went back and looked at it after 145 days of production. So there again, the data I had before actually cut off back in here. I didn't even have this. Pressure is still declining, kind of leveling out. So now that I've got, no question a decline in production, let's see where the reserves come up. Okay, here's our flowing material balance again. We draw a line through the last few data points. sure enough, we're within, certainly the width of a pencil where we were before. So this tells me that, 60 days of production, no decline in rates. I'm getting exactly the same number that I did even after the well is almost depleted. Okay, what have we learned? Short test, transient test, determine only permeability and skin. Long-term tests get you permeability and skin plus the reserves in place. A well does not need to be shut in for a well test. And there again, this is something, this is just a wonderful tool, especially for gas wells. You don't have to shut them in anymore. It's useful determining if you need to drill a well. One thing I didn't show you back there, but if you look on those RTA plots, it'll tell you what your drainage area is for the reservoir. It'll tell you how far out you're looking. And if you've got more acreage, more reservoir out there, you can drill outside that boundary, then you probably ought to go ahead and drill a well. If on the other hand, it shows that you're drilling, that you're draining 320 acres, you might want to rethink it. Certainly look at your economics real carefully to see if the incremental rate acceleration is going to help you out. Good for sizing surface equipment. Here in this part of the world, that's not so critical, but in the Gulf Coast, where you're trying to decide if you're going to size for $1 million a day or 20 million a day, makes a difference. Future production forecasts, that translates directly into dollars, which is really the only thing that interests any of us.